Welcome to the project demonstration of battery management system along with fire protection. So here mainly we are going to do the battery management system with the help of voltage, current parameters, and continuously by monitoring the voltage and current parameters we are going to estimate the SOC and SOH. SOC nothing but state of charging, SOH nothing but state of health. So SOC nothing but whenever the battery is charging, so it has the particular this battery rating is 3.7 volts 3000 mAh each cell. So totally 3 cells we are using, totally 11.1 volt 3000 mAh battery pack. So this battery has a ratings of charging should be done per minute, some percentage, some battery voltage should be increased. So whenever that was not reached, then the SOC will be comes down from the 100% to 90, 80, 85 like that if the battery is not charging properly. Same for the SOH also. Once the load was connected, then if the battery is discharging rapidly, then the SOH values also will be decreases from 100% to less than that, nearby around 70, 80 like that. If the battery is discharging rapidly than the prescribed values. So these are all will be calculated and measured by this Arduino UNO board, which is used to measure the voltages and current. So this is the voltage sensor which are going to measure the voltage, and this one is the current sensor to measure the current which is getting out from this battery pack when we connected this load. So we are using 12 volt 1 amp DC load here. So these are the main two components, and along with the sensors, and the main processing unit is Arduino UNO board. And right, so here we have connected this one CPU fan, so it will come with like that only. Right, this is a cooling fan. Whenever the temperature increases, this is a temperature sensor. So whenever the battery temperature increases due to overload or overcharging or over voltage, then automatically the CPU fan will switch it on to make this cool down. And the next, these two are the selection switches to select the charging levels. Level 1 is normal charging, and when we select these two switches, then these two relays will get switched on. First relay for relay 1, second switch for the relay 2. When this two relay gets switched on, then the battery will get fully charged in faster manner. And this one is the charging circuit which will get the power supply from this transformer. So the main power input in our project is 230 volts AC input to this transformer. So we use it to step down the 230 volts AC to 12 volts of AC, and the 12 volts of AC is input to this regulated power supply board. So from this regulated power supply board we have 3 stages: rectification using the 4 diodes which will act as a bridge rectifier, filtration to remove the pulses and make that pulsating DC as pure DC, regulation to make that 12 volts DC as a pure 5 volts DC, and that is the main operating voltage of our main electronic components in our project. And here the 12 volts DC is parallelly input to this battery pack through this relays. Here we can see these wires. Okay, and the next, this one is a buzzer. Whenever the high temperature is occurred, then this buzzer will get switched on to provide us audible alert. And this one is a temperature sensor, selection switches for fast and normal charging, LCD display which are used to display the status of the project like voltage, current, and temperature along with SOC SOH values, and electromagnetic relays for switching into the charging mode, voltage sensor, and this is the disconnection of the battery pack to this voltage sensor. Means in order to make the low voltage alert, we are making use of this switch. And this is a current sensor to on this load directly from this battery pack. So this is a battery pack, as we discussed, 11.1 volts 3000 mAh and 12 volts DC fan we are using to make the battery pack cooling whenever the high temperature is occurred. And this is a transistor board to switch on this fan. As we know that transistor will act as a switch in our project. So this is the main application of this project. In real time we can utilize this for EV vehicles in order to maintain the life battery to be increased and safety for the batteries whenever the fire accident or high temperature is occurred. So let us see the demonstration. Just on the power supply to this cable, there we can see the welcome message initially on the LCD screen, right, and after that the buzzer will be on and off 2 times. You can see that again. So this is a reset switch to reset the microcontroller. Right, now we can see the voltage 11.75 volts as the battery is under fully charged, and current is 0.00 milliamps, and next temperature is 26.33 degrees centigrade. So everything is normal. SOC SOH values will be calculated after some time based on the voltages captured from this voltage sensor and current sensor. Right, now just I'm going to isolate this voltage from the battery pack. Then we get the low battery voltage, as you can see the 0.00 volts. Now it will provide the buzzer alert to make it charging from this battery pack. Normal charging, right, fast charging. The two switches are selected. We can see the fast charging is occurring. Okay, right. And now once the battery is under fully charged, again automatically the relay gets switched off as indication of protection of the batteries from overcharging. And coming to the current, just on this, there you can see the current also 1102 milliamps. That is going to be around nearby 1 amps of current consumed by the motor which we are using in our project. Right. Okay, and coming to the temperature, just we are using this external heater, but in real time we will place this near this battery pack so that it will measure the battery pack temperature. And whenever the temperature crosses the 43 degrees centigrade, for demonstration we kept that as a threshold value. When it crosses the 43 degrees centigrade, then automatically a buzzer will get switched on, as well as a fan also will get switched on. Right, we can see the fan got switched on again, and when the temperature is coming to the normal, then automatically the fan will get switched off. You can see once again. So whenever the temperature of this temperature sensor is nearby that increases the crosses the 43 degrees centigrade, then automatically the fan will get switched on, and after some time when it is temperature normal, automatically it will be off condition. In this manner we are going to manage the battery system with protection against the fire and overheating using the Arduino UNO board. Thank you.